What's up, guys? This is Mr. Weckeser. Sorry about the last video cutting out short. I was getting a phone call telling me that I was being quarantined, which is always fun. So here's video two. We're going to finish the notes on um, 3-3, System of Inequalities. And these are pizza toppings. And this is just a real life example to show how you can do this with um, pizza toppings. So we have number of vegetable toppings plus number of meat toppings is at least, and let me see if I can actually do this here, at least 5. Never done this before, so you're my guinea pig class. There's my 5. Cost of vegetable toppings plus the cost of, and this is meat toppings. I'm just going to put the word meat. Kind of a cool little red thing here shows up. I might do this in cursive. Might be quicker next time. Is at most 10. This is the word at most. So on top, you see the word at least. So it's between 5 and 10 there, obviously. I guess I could put the at most sign, the inequality, but we'll wait for that in a second. So let V be the number of vegetable toppings and M be the number of meat toppings. So V plus M is greater than or equal to 5. And then write V plus 2M is less than or equal to, that's 10. So we're just following on the notes here. So circle the system of inequalities that is equivalent to the system in exercise 15. And so it's actually going to be this one right here. And it looks exactly like the one above. So you're going to solve for M here. So you can graph it. You need a variable by itself. This M by itself is less than or equal to 5 minus V. So you're going to subtract 5 from each side to solve that inequality. And then this one is going to look like this. Again, you're going to subtract the V. So it's 10 minus V. And then you're going to divide by 2, which gives you that 1/2 V. And 10 divided by 2 is 5. So that's what that 5 is. Number 17, number sense. Circle the types of numbers that can represent the number of toppings you can get on your pizza. You can only do whole numbers, right? You're not going to do half a topping. I guess I do have half pizzas, but we're not going to discuss that right now. So use a graph to the system at the right. Underline the correct number to complete each sentence. If you order 0 vegetable toppings, you can order at most 5 meat toppings. And here is vegetable, right? Here's 0 vegetable, and it goes up here to 5, and there's your 5. If you order 10 vegetable toppings, here's 10. This is just the intercept right here, right? And you can only order 0 meat toppings. 10 vegetable toppings is a lot of pizza. I feel like that's going to weigh your pizza down and maybe make it a little sloppy or soggy. Put that many vegetables on your pizza. All right, number 4, solving a linear absolute value system. And so the graph at the right, what is the solution on the system of inequality? So they have 2 of them. You could use Desmos for this if you wanted to, and you'll get the exact same graph, which is pretty sweet. The absolute value graph, remember, is a V. We studied that in last chapter. And then the Y is less than is right here, right? So the graph at the right shows the boundaries of the system. Shade in Y is less than, so you can shade in here. And I don't know how to do the bucket system with these things in my left here yet. So I'm just going to do a quick little shade. There's my shading down below, right? And then the other one is shaded right here. So actually the only thing we need to worry about shading, and I'll do it in pink, what they have in common is right here, which is crazy. The only thing they have in common is this little V guy right here. And so that is a absolute linear and absolute value. And here's the lesson check. You're going to do this on your own, and then you're going to fill out that Google form for me and tell me that you completed the lesson check, and you get points for that. Tomorrow we'll do the homework, and I'll post a video for the homework and a quiz, and I'll post that video also. If you stay on for a second, I can help you with this. System of inequalities are similar to a system of equation, and that's 100% true. I'll keep the red up there for you guys. Remember, they're exactly the same except for the less than, right, and greater than symbols. And the system of equations is just an equal sign. They're very, very similar. Number 21, the solution of a system of equations is the union of all points on the lines of graphs. That's false. Let's read this again. The solution of a system of equations. So that's just the one point, right? So that's equation is just going to be two lines coming together and you have one solution. The inequality will be a lot of solutions, unless it's two lines that are exactly the same and they have infinite solutions. 22, the solution of a system of inequalities is the union of the points in a graph's inequalities. And that's false also. Remember, it's not the union. It's all the solutions that could make it true. And there's a real world example we learned before about pizza, right? Now answer the question. And the question from above is the solution of a system of linear inequalities a union or an intersection of the solutions of the two inequalities? Justify your answer. It's going to be the intersection, right? So the solution of a system of inequalities is the intersection of the solution of inequalities. So you just write the word intersection here. And I'm going to save this video. Hopefully the volume works. See if I can do cursive now. There's intersection. All right. See if I can save this now.